constructing geometric sequences. This is our lesson. And it goes with 15.2 right out of your text. Your essential question, how do you write a geometric sequence? And you have 2 learning goals for today. I can write a geometric sequence with a recursive rule, and I can write a geometric sequence with an explicit rule. So we did this already with arithmetic sequences. We were able to write a recursive rule and an explicit rule, but now we're going to look at how we do that with a geometric sequence. And so your first interactive slide question here, it says Yusuf was asked to write a recursive rule for a sequence. Recursive. So I'm asking you to remember what that means. Recursive rule. Which of the following is an appropriate answer? And so you have some different choices here. There's more than one correct answer. Okay. So what I want you to do is look at these different options. These are different rules of sequences. And I want you to find the one that represents, or find a example of one that represents a recursive rule. So you have to remember what it means to be a recursive rule. There's something special about it that makes it different than explicit rules, okay? And so I'm going to give you maybe 2 minutes to do this. If I could find my timer back, here it is. Okay, so I have 16 of you in the the Pear Deck so far. And so that'll also give you a little more time to get joined if it's being laggy on your end. All right, so 2 minutes here. Alexa, play.
Do you ever question your life? Do you ever wonder why? Do you ever see in your dreams all the castles in the sky? Oh, tell me why. Do you build castles in the sky? Oh, tell me why. All the castles way up high. Please tell me why. We build castles in the sky. Oh, tell me why. Castles way up high.
That's in 9 responses, 15 more seconds. Pick something, okay? Just make your best guess. Even if you're wrong, it's okay. It's not going to show your name. Alexa, pause. Okay, so I got 14 of you to respond. Out of the 19 of you, I still need 5 more of you to pick something. There should be 21 of us in this, so we're still missing 2 people. All right, so let's see what we came up with. Okay, so we have answers all over, but I'm going to give you some confetti here because the 2 that you picked the most are the 2 that would work. Okay, and so I'm happy that that was what you came up with. My dog is coughing, sorry. Okay, so anyhow, B, this is an example of a recursive rule because it is a function of n that is defined by a function of the previous value, n minus 1, and we are telling, we are saying, giving what f of 1 equals. So you have to say what f of 1 is when it's a recursive rule, and the function has to be a function of the the value of n before it. And again, C has that as well. F of n minus 1 plus 15, and then f of 1 is given here. So that's good. The other ones are not specifically recursive. Okay, so D is kind of maybe close, right? But we don't know what f of 1 is, so D wouldn't count. All right, good. So vocabulary here, this is not new vocabulary. This is the same vocabulary from earlier in the week on Tuesday, but I did want to review it with you again. So when we talk about a geometric sequence, that's where the ratio of successive terms is constant. That means that if you look at the sequence, this list of numbers, and you take any two numbers next to each other, all right, and you divide the term on the right by the term on the left, you're going to get the same ratio, the same fraction or the same amount number every time. And that amount is called the common ratio. It's the ratio, okay, and it's common because it's the same between any two pairs of numbers that are in order. All right, so geometric sequences have common ratios, whereas arithmetic sequences have common differences. Okay, and so this common ratio, we write it as little r, and you find it by dividing a term by the previous term. You can also think, what are you multiplying by to get to the next term? And so for an explicit rule, function of n is equal to f of 1 times r to the n minus 1 power. All right, so basically n just represents the term number. So you have the first term, the second term, third term, fourth term, fifth term, and so on for like ever. And just basically n is which term number. And this is how you can write the explicit rule in general. So you put f of 1. So what this just means the first term in the sequence times the common ratio to the exponent of n minus 1, whatever n this is. And then your recursive rule, so given f of 1, okay, so you have to like know what f of 1 is. You have to know the first term in the sequence. Then f of n is equal to f of the previous term, okay, the function of the previous term, which just means like what is the term before it, times the ratio, okay? The graphic organizer that I shared with you on Wednesday, this is it, okay? So you have a copy of this just by itself. If you wanted to mark it up with Cami and change the way it looks, you can, right? So geometric, this is where we're at today. Recursive formula, so a sub n is equal to r times a sub n minus 1. Now, you do have to define that a sub n is, a sub 1, what it is. It's the first term in the sequence, so you have to give that. And then here, this is the explicit formula, which we were using on Tuesday. A sub n is equal to a sub 1 times r to the n minus 1. And, you know, there's a difference here. You can see we have f of n, right? And then we have a sub n. It's basically the same thing. It's just saying it's a value in the sequence. It's a term in the sequence. And just the n tells me which term. So a sub 3 means the third term in the sequence. F of 3 means the third term in the sequence. Okay, and then we have what these numbers mean here as well. All right, so we're going to do this one together. And so what I would recommend to you as we do this together is to have the Google Meet and your Pear Deck presentation side by side on your screen. You guys remember how to do that? Does anyone want me to show you how to pull tabs out of your main window and then resize them so they could be side by side? If you want me to show you that, you can type yes or give me a thumbs up. You know how to do that, you should do that because it would actually help you because you wouldn't have to toggle back and forth so much, which, you know, you might miss something just kind of following along and copying. All right, so I think we know how to do that. All right, so it says for each geometric sequence, write a recursive rule by finding the common ratio by calculating the ratio of consecutive terms. Write an explicit rule for the sequence by writing each term as the product of the first term and a power of the common ratio. So right here, this is our first problem. We have a table of values. And the top row here, n, This is the term number, 1, 2, 3, 4, 5. So the first term in the sequence is 2. The second term in the sequence is 6. The third term is 18. The fourth term is 54, and so on. And so anytime you're going to write one of these two rules, you want to figure out what is the first term in the sequence, a sub 1. That means what is the first term in the sequence? And you also want to figure out what is the common ratio. Once you have these two pieces of information, then you're just plugging into the formulas to write the two rules. So I am going to show you how to do this. We're going to do this together. All right, so a sub 1, get a pencil. You do probably want to change the size because otherwise you get like this huge writing tool. A sub 1 means first term in the sequence. So when n is 1, a sub 1 is 2. That's the first term in the sequence. That's what this means. So it's 2. And then next thing you want to find is your common ratio. You can find the common ratio by picking any two terms that are together. So I could pick 2 and 6. I could pick 6 and 18. I could pick 18 and 54. It doesn't matter. It's usually easiest if you're picking the first two because, you know, this is just the division problem I'm going to need to do. So I would just do 6 divided by 2. And that would be 3, right? So my common ratio is 3. If I went over here and picked any other pair, I'm still going to get 3. I could do 18 divided by 6, and I would still get 3. All right? Doesn't matter which consecutive two terms I pick, I'm still going to get the common ratio of 3 because to move forward, I'm multiplying by 3 each time. 2 times 3 is 6. 6 times 3 is 18. All right? So once we figure out the first term in the sequence and the common ratio, then we can write these two rules. And I'm going to draw it because if you try to type it with text, these like subscripts, they don't really work too well, okay? So when you write a recursive rule, we do want to define, recursive means we have to say what is the first value in the sequence. So I want to include that a sub 1 is equal to 2, right? So I have to give that part when we are doing the first term in the sequence. And, so I'm going to put and just so you know there's like the two parts here. Now this doesn't actually put that there, but you can add it in, all right? So a sub 1, you're going to have to, you know, remember to do that. What is it? And then I'm going to use this formula here. A sub n is equal to. And now I'm going to replace r in the formula with what r is. R is 3. And then I'm multiplying by a sub n minus 1. So I wrote all this stuff, but instead of, I only replaced 2 things. I replaced what a sub 1 is, and I replaced what r is. And then I also want to add in just a little bit of restriction to what n can be, okay? N can be any number as long as it's not 1, right? Because a sub 1, when n is 1, it's 2. But when n is 2, 3, 4, 5, 6, 7, 8, 9, 10, forever, this works. So we want to say this is for n greater than or equal to 2. And so I'm going to add this up here as well. When you write a recursive rule, that's all the stuff you need. All the stuff I just wrote in green. And now we're going to write the explicit rule. So we were practicing doing the explicit rule on Tuesday. Okay, but we're going to do it now again. With the explicit rule, you don't have to define the first term in the sequence, right? We just go right to the formula. So a sub n, we're going to write equals. And now a sub 1 times r to the n minus 1. I know what a sub 1 is. I know what r is. So instead of writing those pieces, I'm going to actually plug in the values. So it's 2 times r, which is 3, to the power of n minus 1. And so this is the general formula to get any term in this sequence. If I asked you, what is the sixth term in the sequence? You know, you could just look at the fifth term and take this 162 and multiply by 3, or you can use one of these formulas. So a sub n, a sub 6 would be 2 to the 3, 2 times 3 to the power of 6 minus 1, so 3 to the 5th power times 2. That would give me the same answer. And then I could also use this rule. So this rule here, you would have to have them written out. But basically it means if you want the sixth term, well, you have to know the fifth term, which is 162. You just multiply 3 and 162. Okay, but these two rules work for any value of n. Recursive one works for any value of n greater than 2. All right, so we're going to do another one of these because this sequence right here, if you look at the values in the sequence, we started with 2, then we went to 6, then we went to 18, 54, 162. So these values were, this was an increasing geometric sequence. Okay, and it's important to notice that it's an increasing geometric sequence because these numbers are getting bigger, which that puts restriction on your ratio to make sure you're doing it correct. Okay, you kind of self-check yourself. The ratio here is 3, and if your geometric sequence is increasing, your ratio should be greater than 1. All right, and that happened. 3 is greater than 1, so I knew I was doing this correct. You know, maybe you get a little confused. Is it 3? Is it 1/3? You know, how are you supposed to write it? So if it's increasing, it needs to be a number greater than 1. We'll see, though, on this next example, if it's decreasing, then it's going to be a value less than 1. All right, so here's our next one. I have a message in GoGuardian. All right, so again, we have the same directions, but we have a different sequence. N, that's the term numbers, 1, 2, 3, 4, 5. A sub n, we're starting with 10, then we're going to 3, then we're going to 0.9, then 0.27, then 0.081. So we're still going to go through these same steps, okay? And I want to identify what is the first term in the sequence. How about in the chat, if you know, what is the first term in this sequence? You could type it in. Yeah? Angel, you got it. It is 10. We're just looking to see what's first. Okay, the actual sequence is these numbers down here. Yeah, Mauricio, it's 10. Okay, so A sub 1 means the first term in the sequence, and it's 10. Okay, next thing we want to figure out is the common ratio. To find that, yes, so you pick any 2 consecutive terms. To me, the easiest one seems these first 2. Typically, that's the case. So I do 3 divided by 10. And then when I simplify that, 3 divided by 10 simplified. Mauricio, you wrote 1/3. You're right. This is equal to 1/3. If I divide 3 out of the top, I divide 3 out of the bottom, then I get 1. Three-tenths. What am I talking about? There's 1. I'm going to write this as, I can't divide 3 out of the top, bottom. I don't know what I'm talking about. Or me. There's no common thing here. It's not 1/3. It's 3/10. Sorry, I was going with it, Mauricio, but it's not. How do I write so good? Well, I have a mouse. I'm using a mouse to write. If you're trying to use the touchpad, I think that'd be kind of difficult. But just do the best you can. You can use the typing tool too. All right, so 3/10. I can't simplify that to 1/3. It's not 1/3. But I can write it as a decimal. 3/10 is 3/10. So I write it that way. But it's not 1/3. It's 3/10. And you know, if you look at these numbers, they're getting smaller as you move forward. So This is a decreasing geometric sequence. And in a decreasing geometric sequence, you know, if you're doing this correct, then your value of r has to be less than 1, but also has to be greater than 0. Okay, and so that's what we're looking at here. Because these are getting smaller, when I write what r is, it's 3/10, and that is a value that is between 0 and 1, and that's what I want to happen. All right, so recursive rule, we're going to start with writing what a sub 1 is. What is a sub 1? Mauricio has it. 10. It's 10. Okay, we already figured that out. It's first term in the sequence. And then we're going to use the formula here. A sub n is equal to r. What's r? Three-tenths. You could write 3/10, or you could write 3/10. You read them the same. You can write it either way, as a fraction or as decimal. And we're going to multiply that by a sub n minus 1. So all I replaced was what a sub 1 is and what r is to get the formula. And then you do want to include this is for n greater than or equal to 2. Okay, so that's the new rule that we're using. Explicit rule, we've done this before on Tuesday. All right, we're going to use the formula, which is here. A sub n is equal to, and now I got to replace a sub 1 with its value. What's a sub 1? What do I write first? A sub 1 is right here. It's 10. 10 times r. R is 3/10 or 0.3. You can write it either way. Let's use 0.3. And then this number, oops, this number is being raised to the exponent of n minus 1. All right, so that's our recursive rule in green. That's our explicit rule in blue. And now you guys are going to try one of these. The two that I did with you are a little bit tougher, I think, than the one I'm going to give you. Okay, so right here, this is the one you're going to do now. I'm going to give you like 3 minutes to work on it. Even if you are confused, please start it and do as much as you can. If you can only get to identifying the first term in the sequence, well, then that's all you got to. But try to do as much as you can. Try to use those formulas. You're only going to learn it by trying it, and then we'll go over it. So I'm going to give you 3 minutes. Alexa, play. Hate it or love it. Okay, so 6 of you have started writing. Thank you to the 6 of you. The rest of you guys, start writing something. Participate. That's how you get your attendance credit. Okay, we're up to 11 out of 22. Come on, the other 11 of you. You need to do something. What's the first term in the sequence? Okay? First term in the sequence. At least do that. A sub 1, first term in the sequence. When n is 1, what is a sub n? Alexa, pause. Okay. So let's see what we came up with here. A sub 1 is 5, absolutely. And our common ratio, well, if it was 4/5, okay, and this is an easy thing to kind of do here, but see how we're getting bigger as we move forward? So that means my common ratio has to be a number larger than 1. 4/5 is a proper fraction, which means it is less than 1. So it's not 4/5. Common ratio, 5. Good. I'm sorry. First term of the sequence, 5. Common ratio, 5 divided by 20 is 4. Well, 5 divided by 20 is not 4. 5 divided by 20 is a number less than 1, but 4 somehow is the common ratio. So this is partially right. That fraction's wrong. We have the ratio reversed. It should be 20 over 5. I don't know what that says. That looks like 4/5. 4. Okay, so here we go. First term is 5. Common ratio is 4 because 20 divided by 5 is 4. Yes. And the recursive rule, oh, this must have took a lot of time. They had to probably type 2 different boxes to get the n like this. A sub n is equal to 5. So this would be a sub 1. We would want a 1 right here. And then 4 times, well, we're working with it. We got these 2 parts correct. Okay, a sub 1 and r are correct. It should be 5 and 4. 5 and 4. 5 and 4. 5 and 4. And now we're starting to write it out. Okay, cool. All right, 5 and 4. A sub 9. Okay, 5, 4. So, you know, we got this part down. We could figure out what is a sub 1. We could figure out what is the ratio. So when you do the HMH assignment today, and you have to write these rules out, it'll be a little bit easier because you're going to have like the skeleton of the formula there. And what you need to do is fill in the blanks. So you're basically filling in a sub 1. You're filling in r. So it'll be a little bit easier. All right. So for this one, time-wise, where are we at? 9:52. Let me see what time we have till. We're here till 10, so we have 8 minutes. All right, I am going to go back to this so you can get the correct answers here. We're not going to get to all of the slides in this presentation. I did it with my other class as well, but you know, you guys were good at figuring out. Oh, I've lost my screen. Here's my screen. There it is. Way the recursiveness is yeah. So we'll get it down. Don't worry. It's, you know, it's confusing at first. It's fine. It's fine. Don't worry about it. So a sub 1, you know, that's where we got the 5. And then the ratio, you just take 2 consecutive terms. Make sure it's the term divided by the 1 before it. And that's where we got the 4. And then the recursive rule, you always start with what is a sub 1, which is 5. And then you're going to put a sub n is equal to r, which is 4, times a sub n minus 1. So I'm still just writing a sub n minus 1. The only thing that I replaced from this is just the value of r. And even though it doesn't say it, you have to include what is a sub 1 in this value here, 5. Right? And then we just write this is for n is greater than or equal to 2. So in HMH, you're just going to be plugging in the missing pieces. It'll be easier. Explicit rule. Wow, it's raining really hard right now where I'm at. You have like an aluminum thingy outside and like the rain hits it really loud. That made me lose my train of thought. So explicit rule, and then we're just taking this one here. We're just going to write it out exactly like you see it, but when you get to a sub 1, you're going to replace it. When you get to r, you're going to replace it. Okay? So it's just a sub n is equal to a sub 1, so 5 times r is 4, and then n minus 1. All right? So you're just replacing a sub 1 and r. That's why you should figure out what those two things are first. And then like here, oh, no rain over there. I'm sorry. So here we just replaced this value. That looks like an O. But you have to do this value and this value. So those two things I circled in each one are the only things you have to replace. The rest stays the same. Okay. The next slide I am going to show you anyways. You don't have to do these ones, but because we didn't get to them, you know, we can look at a sequence without it being in the terms of a table, right? So if we just looked at 520, 80, 320, so on, it'd be these numbers here. And so when it's written this way without the a sub stuff, you can use these rules, which are given to you. So I'm going to put on student paste.